There was a question regarding the ClogP in Lemke's that uses the pi values, and also Lipinski's. Question is that, are they the same or are they different? My answer to you is that they are used for different things. The use is to predict solubility. In Lipinski's, the use is to predict the drug or the compound oral viability. Two different things. Yeah? So in this case, for example, if you remember, I mentioned log-P, calculated log-P. If it is less than plus 0.5, it predicts solubility at about 3%. And if you take the US pharmaceutical standards, if you see the table here, is from the US pharmaceutical standards. At 3%, that would mean you take drug X, 3 grams of drug X, and try to dissolve in 100 ml of water, and it gives you, the table gives you drug X as being sparingly soluble. So it means that Lemke's prediction, using the pi values to come up with the ClogP, would put drug X as sparingly soluble at 3% solubility. And of course, there are other ways to predict solubility using ClogP, and there are a lot of computer software out there to predict solubility using the ClogP. Yeah. Now, on the other hand, Lipinski's rule of 5 is the rule of thumb for scientists and medicinal chemists to predict the overall oral bioavailability of a drug candidate, yeah. Especially at the lead molecule stage. All right. So a particular molecule would have poor oral absorption if the molecular weight is more than 500, if the HBD equal or more than 5, if HbA is more than 10, and with ClogP is more than 5. The point now I want to make is that, say if a ClogP is plus 3.5, yeah. So what does it tell you? I would urge you to pay attention to the question. In many cases, I've seen that you've come up with the answer first, and you've written the answer on the question on the answer sheets and answer scripts without really reading what the question wants from you. Yeah, so please pay attention to the question. So if a question asks for solubility, then ClogP plus 3.5 may means that the compound is not that soluble in water. But if a question asks for Lipinski's, yeah, so, and you have calculated the molecular weight, the HBD, the HbA, and now it says the log-P, the ClogP for this particular lead molecule is plus 3.5, then of course the compound fulfills one of the rules of Lipinski's. So I hope you are clear on this matter, the use of ClogP in Lemke's and in Lipinski's rule of 5. The next one is I would like to answer 2 questions that was posted on Friday. You can see from there, asking that the problem the student is facing is that he or she cannot identify the correct structure of chloramphenicol. You've shown here my lecture notes, Also shown here the search that you have made, and this is a question where you have to apply what you have learned in the first year, particularly in the first year, first sem. Yeah. So please, I urge you again to go to some YouTube channel, for example, to find out how can you assign the RS configuration using Fisher projection. Yeah, shows you how to convert a particular molecular structure into a Fisher projection. And if I actually fast forward this, it will also show you how to determine the RNS configuration. So have a look at it. Yeah, I'll post the link in the Facebook in the comment section. The second question is about the missing link in Hugo and Russell book. On the beta-lactam, if you go to beta-lactam on this 3.0 beta-lactam 2, you get into something like this. On the 14th slide, where if you click on this 14th slide, you'll come back. You come to this one where it says to learn further about antibiotics. You can click on this scribed, yeah. And if you click on that, you actually find this removal notice. So where else can you go to look for this particular reference? You can always go to USM library. Not the second one. You need to go to the first one where it holds all the pharmacy books. With that, all the best for your exam. I hope everything goes well for you. Thank you.